The Earth may be considered to be a uniform sphere of radius 6,370 kilometers, spinning on its axis with a period of 24 hours. The gravitational field at the Earth's surface is identical with that of a point mass of 5.98 times 10 to the power 24 kg at the Earth's center. For a 1 kg mass situated at the equator, calculate using Newton's law of gravitation the gravitational force on the mass. Now F equals to gmm over r squared. That's what Newton's law of gravitation says. So substituting values, we have F equal to 9.83 newtons. Determine the force required to maintain the circular path of the mass. So the centripetal force is mr omega square. Substituting values, we have F equal to 3.37 times 10 to the power of minus 2 newtons. Deduce the reading on an accurate Newton meter supporting the mass. So let's take a look at the free body diagram. So the mass has a weight and is also acted by the tension. So the resultant force is W minus T, and based on Newton's second law, resultant force equal to ma. So the tension will be 9.80 newtons. Okay, using your answers to C, state what would be the acceleration of the mass at the Earth's surface due to the gravitational force alone. So A is equal to F over m. So we have the acceleration to be 9.83 meter per second square. Using answers to C, state what would be the acceleration of the mass at the Earth's surface due to the force measured on the Newton meter. So similarly, A equal to F over m, so we get A to be 9.8 meter per second square. A student situated at the equator releases a ball from rest in a vacuum and measures its acceleration towards the Earth's surface. He then states that this acceleration is the acceleration due to gravity. Comment on his statement. Okay, the statement is not correct. The acceleration he measures is actually due to the acceleration of free fall and not the acceleration due to gravity. The student and ball are also moving in circular motion. Therefore, part of the gravitational force applies a centripetal force to keep the ball in circular motion.